Um, anything, anything, appliance or activity, anything, appliance, activity, anything goes. What do you think you use? How do you think you use, or what do you think used the most energy for you yesterday? So in the chat, write down what you think you used the most energy for yesterday. It can be what you did. It can be an appliance you used. It could be anything you want. Freedom of choice. How powerful is that? You can choose what you think used the most energy for yesterday. So take a few minutes to write down what you think you used the most energy for yesterday. Um, I don't think that there's a correct answer. It depends on what you did yesterday. Um, so in the chat, write down what you think you used the most energy for today. Yesterday. My math homework. That's hilarious. Washing machine. Washing machines use a lot of work for sure. Going hiking for me and driving in a car for an appliance. I think I use the most energy going around on a long hour-long walk around my neighborhood because I was complete couch potato the rest of the day. Welcome to the club. I did not do a whole lot yesterday. AC, the AC, the air conditioning could/slash uses a lot of energy. What else do we think could you think we used the most energy for yesterday? You would be surprised which things are very energy intensive. We'll take another minute or two baking beets. Trick question, it's sleeping. Your brain actually consumes a lot of calories when it's sleeping. So it's like not it's not like incorrect. I know that like it seems weird because it's like you're sleeping, you're not doing anything, but like that's when your body's like repairing all the muscles. That's when you're like clearing out all the junk from your brain too. So like sleeping actually does burn a lot of calories. Believe it or not. Does that mean you should just sleep more as a way form of exercise? Probably not. But I mean, but yeah, you'd be surprised. You'd be surprised, right? Because you think about this, your body's like not doing nothing when it's sleeping. It's repairing all the damage that you did to it. So all the damage you did from watching TikToks and um, and wasting all your time on social media, right? That destroys your brain. That removes the few brain cells you already have. So you have to repair that during sleep. Diving practice and singing. I did not know you were a singer. I'll have to ask you about it next week. Okay, so I think we'll take about maybe one more minute baking beets. That's interesting. Not a big beet person, but then again, I don't really eat beets, so I don't really sure. Um, yeah, a lot of people are really into beets. Um, I'm sorry. I think I made a mistake with the link. Gosh darn it. So who? What are you doing? Good question. I swore I changed it. Okay, it should be changed now. Okay. So the graphic organizer link, I just fixed it. So I'm also going to link it right here. So if you want to fill that out as you go along. If you're also comfortable taking your own notes, you don't have to fill it out. So it's really up to you. I think it's just helpful just to fill it out if you aren't used to taking notes. If you are good at taking notes, it's good practice to take notes by yourself. because in college your professors are very lazy and they will not give you anything to write on. Personal experience. Okay, so okay, so today it's gonna be fairly fast paced, I think. We have a lot to cover. We have 7 instructional days left, and out of that, I'm gonna be using like 3 or 4 of them just for instruction. So we're gonna be going fairly quickly through things. So yeah. So as you probably know or maybe may not know, we're gonna be covering energy now. We will still talking about roller coasters, but for now we will be focusing on energy. Um, so for today, there is a graphic organizer that you can fill out. If you want to take notes by yourself, you can also do that as well. It's up to you. And then if we have time today, we're going to keep working on Roller Coaster Tycoon. There is an energy portion that I just added to the assignment that relates to today's curriculum. So we will do that if we have time afterwards. Maybe we'll have time. I think we'll have time. Hopefully we'll have time. But yeah. So to get started, basically, um, what is energy? We've sort of heard it a lot. Sometimes it can actually be hard to like think about what energy concretely is. But basically, energy is basically the ability something has to create change. So it's if there's no change happening, there is no energy being used. If you want to change anything, you have to use energy. You can actually measure how much energy an object has. Um, so you can have a lot of energy, you can have very low energy, right? Energy is a measurable quantity. It's not just like a Fugazi kind of thing where it's like imaginary. It's not pixie dust. Energy is measurable. It does have a certain amount of energy. All objects have energy. There are many different forms of energy. The way energy can sort of the way energy sort of is utilized is you can either store energy, and that's what we call a form of potential energy, potential, or energy can be used in some sort of motion. So there are different kinds of motion energy essentially. Basically, energy can either be stored or it can be used. And those are, what you do with energy basically. So TLDR, energy is basically the ability something has to create change. You can measure energy and you can either store energy or you can use it in some sort of motion. Oh, what happened? Uh-oh, the presentation disappeared. Gosh darn it. OBS does this really weird thing sometimes where if I switch to a different tab, it like disappears. So now you can see it. Wow, nice. Cool. Yeah, OBS does this thing where it does a really cute thing where if I switch tabs, it like doesn't work. Um, okay, now you can see it. Now you can write down stuff. I'm choking on water. I don't know if you do that, but I drink water really fast. I talk really fast. Some teachers don't use slides, so I never know if I'm supposed to see. Well, yeah, so if I'm talking, there generally should be a slide or a whiteboard. So if neither is showing up, then I'm doing something wrong. So yeah, that's definitely my fault. Um, yeah. Okay, so that's what energy is. What energy is supposed to do is, and what energy does, not supposed to, what energy does is it creates change. So we usually refer to creating change as, or we could refer to it as creating change, causing change, or we could refer to it as doing work. What? Gosh, I I could have sworn I like changed all the links and stuff, but it doesn't. But I didn't apparently. Okay, let me change the link as well. But basically, what energy does is it creates change. Um, you can you can create change with it. You can do work with it. Um, what we refer to as doing work itself is actually a measurable quantity. Basically, what basically work basically means doing change essentially. Um, and in terms of what changes energy you can use energy to create, you can use energy to create changes in your temperature. So you can heat or cool something, and that is one way that you can use energy to create change. You can change the state of an object. So liquids, solids, and gases, they all have different amounts of energy. Um, and when you change the temperature of an object, you're sort of changing the atomic structure of them. You're basically, making the molecules vibrate faster or slower, and that sort of changes the structure of it. It causes it to either be, solid, liquid, or gas. And that in many ways relates to the temperature of the object, and you need to sort of apply heat energy to do so. But yeah, energy, you can change the temperature of a heating or cooling something. You can also change the state of an object. So those are a couple of ways that you can use energy. Some other ways that you can use energy is so you can use energy to change the temperature. You can change the energy to change the state. You can also use energy to change the volume of an object. So you can use it to blow up a balloon. You can also use it to crush a piece of paper. So when you change the volume of an object, you're also using energy. Um, so that's one way you can also use energy. Another way of using energy is to build or to destroy something. So again, this many times it sort of relates to changing the structure of an object. So when you're building an object, or when you're destroying it, a lot of the times you are actually changing the structure of it. And to do so, you require energy. So energy, I guess you can also think of it as energy is used to destroy or build stuff as well. That's another way that energy could be used. So basically, energy, anything you do in the world, anything that happens is using energy in one form or another. So even when you are sleeping, you're also using energy. So you can't have anything happen without energy. Probably the most common way that you use energy is in terms of making something move or making something stop moving, or to make something move or to make something stop moving. So in order to make your drive a vehicle, or in order to walk or run, you need energy to do so, and then you also need energy to stop it, right? So I guess one yeah, so you need energy to speed up a vehicle. You also need energy to stop it. You need energy to make it turn. So anytime you're sort of changing the motion of an object, you are using energy to do so. And to give and to utilize to give these objects energy, most of the time you use some sort of fuel. So so you most of the time vehicles use some sort of fuel. Humans actually use fuel as well. We just don't use gasoline. We usually use like food as a fuel. But yeah, so in order to change the motion of an object, you also require energy for somewhere else. And then a lot of times you use some sort of fuel. So in terms of how we use energy, besides the objects we use, bold assumption: humans don't drink gasoline as fuel. That's true. I'm sorry. I shouldn't be. How's it going? I shouldn't be assuming what people eat and don't eat. I generally assume people don't drink gasoline, but that's you do what you do, right? You had a third of a pancake just now. I, I love pancakes. Corn-based fuel is fuel for all. That's true. So God, I'm gonna go on a tangent here. There's this one kid in my high school who drove this massive truck, very massive. I'm talking like the biggest truck you've ever seen. It was so big it could barely fit in a parking spot, and his he made his truck run off of ethanol, and so he would get all his fuel from the Chinese restaurant next to our school. And so every time he drove the truck, it literally just smelled like Chinese food. So it smelled really good. The truck was stupid though. It was way too big and it was just obnoxious. But it was really cool that it smelled like food. Corn sucks. Yeah, corn does suck. But it is what it is. So we also need energy. That's because when you are born, you're not very yoked. You're pretty small. You haven't started lifting yet. So in order to grow and become yoked, you need energy to grow. That's because your structure is changing, right? You're getting bigger. You also need energy to make yourself move. You also need energy to heal or grow new cells. So when you get injured or when your cells die, as they naturally do, you need energy to heal or to grow new cells. And so even when you're sleeping, you're using energy. Um, and you get all this energy from your food. And yeah, so your body eats food, it breaks down the energy stored in the food, and then it uses the energy to do stuff. So I guess if you were to think of like a one sentence summary for what energy is, basically you need energy to make something happen. If you don't want something to happen, you don't need to use energy. If you want something to happen, you need energy. So basically you're using energy for everything in the world. Um, so in terms of how we measure energy, we use the following units. There are a couple of other units that we can use sometimes. This is the main one. This is the metric unit. This is the standard unit. We use the term joules, and not the fun kind of joule, the unfun kind of joule that you're used to. This is joules, the more responsible type of joule. So this is the metric unit for energy. This is a unit we This is the metric unit for energy. So usually, what you might say is I have 100 joules worth of energy. They are using 1,000 joules of energy. That's usually how we refer to energy is joules. If you want to know what a joule actually is, it's 1 kilogram times meters squared divided by seconds squared. Or you can also think of it as 1 Newton times meters. I think the conversion is helpful because sometimes if you like aren't sure how to convert units to another unit, you can sort of remember that. Um, in general, though, as long as you are keeping all of your units, so here's the thing about units, as long as you're keeping all your units in standard units, you never have to worry about converting stuff. So this is why it's very good, helpful to convert kilometers to meters first, because meters is a standard unit. If you're doing things in kilometers, then you have to worry about this conversion from kilometers eventually to joules, for example. But if you're already using everything in meters, already using everything in kilograms, already using everything in seconds, when you do some sort of calculation, you will end up with joules. So it's very helpful to just sort of do everything in terms of good units. But if you ever want to sort of double check your answer, a unit of joule is kilograms meters times meters squared divided by seconds squared, or 1 Newton times meters. So force times distance essentially. Um, some other ways that you might hear of how energy is used. Have you heard of something called calories, which you may or may not have heard of? Um, calories is a unit of energy that we usually use to refer to food. We also a lot of times we also use a term of energy called kilowatt hours that is usually for appliances. Um, these are all ways of measuring energy, but the standard way of measuring energy is joules. And that is what we will be using in this class, joules. So there are many different types of energy. We are going to cover 8 different types in this class. There is many more. Um, here are some of the 8. Here are the 8 we are going to cover. We are going to cover kinetic energy. We are going to cover thermal energy. We are going to cover radiant energy, vibrational energy, gravitational energy, chemical energy, elastic energy, and electric potential energy. So those are sort of the 8 types of energy that we are going to cover. Yeah. So we're going to go through each one of these different energies, and then we are going to sort of talk about what these energies are. You probably have heard of some of these energies in one way or another. You probably have heard of the term kinetic energy before. This feels like it would make for a great BuzzFeed quiz. The problem with a BuzzFeed quiz is usually they are assumed that you're brain dead when you go into BuzzFeed. This might be too intellectual for BuzzFeed. I don't know. BuzzFeed is usually like, what Harry Potter character are you? Or what Harry Potter house are you? And not a science question. What type of energy are you? Okay, I see that. I can see what kind of type of energy are you. I can see that. But again, that's assuming that BuzzFeed's target audience has a brain. Not saying that you guys don't have a brain. I'm just hoping that you guys do. Okay. Um, so the first type of energy we're going to talk about is kinetic energy. So basically, kinetic energy is the energy you would probably have seen or heard of at some, maybe have seen or heard of before. This is basically the energy an object has due to its motion. And so basically, if an object is moving, it has kinetic energy. The kinetic energy of an object is determined by two things, its mass and its velocity. The more mass an object has, the more kinetic energy it has. The more velocity it has, the more kinetic energy it has. So if you get hit by a ping pong ball versus if you get hit by a bowling ball, the bowling ball is going to hurt a lot more because it has a lot more mass. If you get hit by a car going 60 miles an hour versus if you get hit by a car going 1 mile an hour, the 60-mile-an-hour car is going to hurt a lot more than the 1-mile-an-hour car. So the mass and the velocity of the object both contribute to how much kinetic energy you have. Kinetic energy is one of the easiest energies to calculate, which we will do later on. But for now, this is more of a qualitative definition of kinetic energy. So once you're sort of written down whatever you want, in the chat, I want you to give an example of an object that has kinetic energy. So what kind of object has kinetic energy? You could probably make an argument for pretty much every object. Almost every object has kinetic energy. But what kind of object, give an example of an object that you think has kinetic energy. A ball. That's true. A ball does have kinetic energy. My dropping grades. That's hilarious. A car, a soccer ball. Those are some good examples. Any other examples of kinetic energy? Things. That's really specific. Mr. Who. Wow. That's how you get extra credit in the class. A bullet has kinetic energy as well. Any sort of projectile has kinetic energy. Any other ideas? A hand. Yeah. Have you ever watched like the people who? Have you ever watched like the slapping contests on YouTube? Those are really entertaining. Yeah. It's like they have to like keep their elbow like stationary, and it's just basically like how much energy. Those are really interesting. Really interesting. A fan has kinetic energy. An arrow, yeah. So an arrow, any sort of projectile, has kinetic energy. Those are some good examples of kinetic energy. Go ahead. Um, okay, so that is one type of energy. Another type of energy that you may have heard of is something called thermal energy. And this is energy that is created by the vibration of molecules. Basically, when molecules vibrate, they generate a lot of thermal energy. I mean, you could argue that this is also kinetic energy, but basically, the thermal energy of an object is basically the temperature of the object. And the temperature of an object basically refers to how quickly the molecules are moving. Hotter molecules have more thermal energy. So basically they move and they vibrate a lot faster. That's why gases usually have a lot of thermal energy because they're moving and vibrating very fast. So there's all the molecules, you can argue the molecules have a lot of kinetic energy as a result. Colder molecules have a lot less thermal energy, and thus they move and vibrate a lot slower. So yeah, so basically thermal energy is basically the energy of cause created by the temperature of the object. What you need to know is that basically that temperature relates to the molecules moving very quickly or very slowly. Hotter objects have molecules that move very fast. Colder objects have molecules that have less thermal energy. AP Chem for the win. I don't remember anything for AP. No, actually, I don't know. I remember some things in AP Chem. I remember my stoichiometry. Okay, so what I want you to do is I want you to give me an example of an object with a lot of thermal energy. So give me an example of stoichiometry, all caps. That's really funny. I don't know why you're so excited. So give an example of an object with a lot of thermal energy and an object with a very little thermal energy. So what is an example of an object with a lot of thermal energy, and what is an example of an object with very little thermal energy? Thermal California population 1333. Is that a reference? Are you saying that California is warm? Are you saying that California is warm? Okay, okay. I wasn't sure that if what you were referring to. Lava is very hot. Antarctica is very cold. Well, Antarctica is getting warmer, so global warming for the win. Yes, the sun's a great example of an object with very little thermal energy. Very little thermal energy. I agree. A cup of hot tea, little, an ice cube. So hot take. I don't drink tea. I don't drink tea. Nuh-uh, I don't drink tea. It's very hot take. A lot of people find it very controversial, but I don't drink tea. I don't drink coffee either. I'm all natty. Yeah, yeah. Don't worry. I'm all natty. I'm all natty. Um, yeah, I don't drink caffeine. Makes me really wired. Like even a little bit of caffeine, I just like go crazy, and I just I've had Red Bull before. Again, they make me really wired. So like it's yeah, caffeine does weird things to me. If you think I'm crazy right now, wait till you see me on caffeine. Um, 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 something at absolute zero is very cold. I agree. Boiling water is very hot. Ice cube is very low. Is very cold. What? Why not? It is controversial. Hot take. The sun at night is very cold. That's uncaffeinated tea, like herbal teas. Yeah, but also drinking coffee to listen to this. Boo, boo, coffee. Also, by the way, coffee is not a personality. So if you say that I like coffee is a personality trait, you should go home and rethink your life. So coffee is not a personality trait. Um, there's uncaffeinated tea. I don't drink uncaffeinated tea either. I just like tea is just like kind of like I like water. Water's good. Yeah, yeah, yeah. So caffeine withdrawal. We should get to college. That's a real issue. Caffeine addiction, real issue. What do you drink when you're sick though? I drink water. Yeah, that's like yeah. It's juice is like really has tons of sugar and it's bad for your teeth. It's just as bad as soda. Yeah, water is good, but leaf water is even better. I have no idea what leaf water is. If this is like one of those out, okay, like LaCroix, what's it called? LaCroix, LaCroix. Yeah, yeah. Pellegrinos are OG. Like LaCroix is just um, yeah. Leaf waters tea. Oh, okay, okay. I get it now. Okay, but yeah, but hot take: plain water is very good. Plain water is very good. Okay, so also I'm gonna tell you. So an object that has a lot of thermal energy, an object that has a lot of thermal energy is my new mixtape. As it's my new mixtape is hot. It's fire. It's supposed to be a joke. You're supposed to think that I'm okay. You know what? Fine. I haven't planned for like a while too, but there's like no response. Nobody even said anything. Okay, cool. The next time energy we're gonna cover is radiant energy. And this is thank you for laughing. I think it's funny. Radiant energy is energy that is carried by like electromagnetic waves. So basically, it's light carries is radiant energy essentially. But there are many different forms of light. So usually we refer to light as like being visible light, light that you can see. But there are other kinds of light as well. Um, these are kind of interesting because they are just pure energy. Light is literally just pure energy. There are many different kinds of light because light has an electromagnetic spectrum. The amount of energy in a light wave is dependent on its wavelength and its frequency, which you may or may not have heard of at some point. Basically, a light wave that has defined pure energy, it's okay. So um, by pure energy, I mean like usually a lot of times an object's energy is defined by like its mass, like equals mc squared. And whereas energy, it's just like energy in itself. There's like no mass. There's no like bonding things. It's just energy. I mean, it's not even, and there's no like, or the object has speed, and that determines how much energy it has, or its position. Light is just light. Light, and its energy is like independent of anything else, other than its wavelength and its frequency. So if something has a low wavelength, basically very short wavelength and high frequency, those have a lot of those are high energy. So X-rays, gamma rays, UV rays, they're all high energy. That's why they're very dangerous. UV rays are, they basically give you skin cancer if you have too much of them. X-rays, that's why you have to wear the lead thing, the lead plating when you get an X-ray, because X-rays are like very high energy, and they can be very bad for you in prolonged amounts. Gamma rays are the most dangerous, and there is nothing on Earth that is powerful enough to reduce the effects of gamma radiation. So if you've ever watched Chernobyl, the people got wrecked by gamma rays, and it's like really bad. So yeah, gamma rays are very nasty. Don't mess with them. However, if you were to mess with some light waves, you can mess with the low energy ones, which are basically the opposite. They are high wavelength, low frequency. And these include stuff like microwaves. So microwaves generate a form of radiation called microwave radiation. So radios generate a kind of light wave called radio energy. And then there's also infrared energy. These are low energy, so these are a lot safer to mess with. So these won't really hurt you at all. So radiant energy is also present all the time, because everything sort of emits off radiant energy in some form or another. So basically, radiant energy is always present day and night, because everything is emitting some sort of radiant energy. So in the chat, I want you to give an example of an object that emits radiant energy. What is an object that emits radiant energy? I mean, technically, she would emit radiant energy. Technically, that's true. I used to be afraid of microwaves because I heard that they were a type of radiation. They are a type of radiation, but there are good types of radiation and bad types of radiation. Good types of radiation, or I don't know if good is the true, but they're very low energy, so they're not going to hurt you. The cleric, is this a reference to like a standard RPG game? Because I mean, it's technically true, but it's sure, yeah. Phones emit a lot of radiation. That's true. The phones will emit all kinds of radiation. Microwaves, that's true. Lamps, most things. Wow, it's really true. Most things emit. I think technically all things emit some sort of radiant energy. The sun emits radiant energy. Walkie-talkie. So yeah, great example of radiant energy. Love those. Love reading those. So that's I think the third type of energy we covered so far. The fourth one is vibrational energy. So vibrational energy is energy of waves carried through molecules bumping into each other. So basically, it's like a bunch of molecules and they're basically just slamming into each other. And then that creates a type of energy called vibrational energy. And it's more than most part, sound is probably the best example of it. So when you say something, what basically happening is you are pushing air out from your mouth, and it's basically causing these molecules to just like bump into each other and create sound. So that's why there's say no one can hear you scream in space, because in space there's like it's basically a vacuum. So there's no air in space. So if you say something, you can't hear it because you can't like make the molecules bump into each other. So yeah, so that's why you can't. No one can hear you scream in space, because there's no molecules for that. Are these the most easily modeled with trigonometry? Any wave is modeled with trigonometric waves. Yeah, so you'll learn that if you do take physics in college, I think most of the time you just treat waves as just being waves. You honestly don't even really differentiate between the types of waves, because waves are just waves. So you just model any of them with a wave function, which is a trigonometric function. So you don't actually like separate them once you get into like more higher level of physics, because there's no difference essentially in terms of the grand scheme of things. So in the chat, I want you to give an example of where vibrational energy could come from. Where can you see vibrational energy from? Where can we see vibrational energy? What are some examples of vibrational energy? Vibrational energy. Vibration. sound, the noise that's coming out of my speakers right now, the horrid noise. Are you saying that my voice is horrid? That's how you upset someone. Radios, my new mixtape. Yeah, I'm gonna release a fire mixtape one day. Thank you. I'm finally. I thank you for finally appreciating my musical talent. My fire mixtape. The construction workers down the street, they're very loud, and I can hear the vibrations on the ground. True. Speaker system. Yes, that's great. Um, yeah. So yeah, great examples of vibrational. Can you drop something on SoundCloud? Yeah, I'm just gonna quit being a teacher and just become a SoundCloud rapper. That's my new profession. Jet engine. My friend is making a mixtape. You need to get a feature. So back in the day when I did cross country in high school, freshman year, what we would do is all my friends would do these like really crappy rap battles. Where it'd be like, yo, like, and then it'd just be like these horrible rap battles. Those are hilarious, by the way. So I just want you to know I have my freshman year musical experience as a wannabe rapper. Not really. I was just really bad. I don't think I even participated because I was so insecure about my rapping skills. Um, so maybe I'll feature on it. Okay. So that is vibrational energy. The next kind of energy we're going to look at is gravitational potential energy. You do look like an XC kid, another XC kid. I am an XC kid. I still wear a lot of my cross country shirts and track shirts from high school. They're all really good shirts, so I just wear them all the time. So yeah, those shirts are probably close to 7 or 8 years old now. Very interesting. So gravitational potential energy is probably one of the most important energies that we're going to look at this class. Kinetic energy and gravitational potential energy are the two most important energies we're going to look at in this class. Gravitational potential energy is basically the energy an object has when it gets lifted into the air. So for example, if you lift a pencil in the air, so the reason why gravitational potential energy is called a potential energy is because let's say, for example, you lift a pencil in the air. So when you let go of the pencil, it starts to fall. So basically, when you lift the pencil in the air, you are storing energy in its position. And then you have all this stored energy and it's waiting to do something. It has all this potential to do stuff. When you let go of the pencil, it starts falling, and all that potential energy gets converted into kinetic energy. So I guess a good way to think about potential energy in general is basically when you're storing energy and you're preparing, and it's preparing to do something. And when you let go, the energy starts doing stuff, and it usually gets converted into some sort of kinetic energy. So gravitational potential energy is the energy you get from storing energy from its position. And it's usually some sort of elevation. It is some sort of elevation. So basically, yeah, you separate something. When you lift something up, you're giving it gravitational potential energy. You're storing energy, and when you drop it, it gets translated into kinetic energy. How much gravitational potential energy it has depends on its mass and its height. So the more massive an object has, the more gravitational potential energy it will have. The more height it will have, the more gravitational potential energy it will have as well. So yeah, so basically bigger objects have more gravitational potential energy. Taller objects have more gravitational potential energy. I'm not going to ask you for an example here because it's just you lift an object up and it has gravitational potential energy. But I'm sure you can come up with some fun examples um, for that. So that, and you can also calculate this very easily. This is probably, so we're going to be mostly calculating two types of energies, kinetic energy and gravitational potential energy. These two are very important. You need to know them, and you need to know how to calculate them. We'll look at the calculations later, but you need to know how to calculate kinetic energy. You need to know how to calculate gravitational potential energy. If you can't calculate those two, it's going to be rough. So calculate those two. Luckily, they're actually not very hard. It's actually, in terms of math wise, I think it's probably going to be one of the easiest math stuff we do this semester. So another chemical potential energy is called chemical potential energy. So chemical potential energy is energy that's stored in the bonds of molecules. Basically it's a fuel. So gasoline, for example, is a great example of chemical potential energy. Because when you burn it, you're basically breaking down the bonds in the molecules and the hydrocarbons, to be more exact. And then that energy gets released, and you can use that to make an engine go. You can also the food you eat, that generally has energy in the form of glucose. So when you break that down, that also releases energy that your body uses. So yeah, so in the chat, I want you to give an example of some fuels that might have chemical potential energy. So basically, any sort of fuel has chemical potential, has sort of bonds in the molecules. That is a form of chemical potential energy. So what are some fuels that have chemical potential energy? Dinosaurs. Yeah, that's true. So dinosaurs, not just dinosaurs, but any sort of living object that gets, what's the word? It's like when they get like, I don't remember what the word is called, but like when they go through the whole like sedimentation process thing, they like get compressed, and then they do like the whole thing, and then eventually you burn them in fossil fuels. That's why they're called fossil fuels. C4. That is true. That is true. I guess explosives are a good form of chemical potential energy. I don't know where you came up with that idea, but that's funny. Okay, so yeah, chemical potential energy, food, fuels, fertilizer. Uh, if you burn fertilizer, yeah, I guess you could. Yeah, fertilizer has chemical potential energy. Yeah, for sure, yeah, for sure. Okay, so that's a chemical potential energy. The penultimate potential energy, or the penultimate energy we're going to look at is elastic, which is another way of calling it is spring potential energy. So this is basically so basically when you stretch or you bend an object, you are giving it elastic energy. So when you release it, it gets converted into kinetic energy. So if I take a rubber band and I aim it at someone and then I let it go, it's gonna all the energy that was stored from me stretching it. When I release it, it's gonna get converted into kinetic energy. That's why it's called a potential energy. I'm storing energy in the motion of the in the tension. Aha, buzzword. So when I that's actually a good buzzword. So when I stretch an object, I'm creating more tension with the elasticity, and when you let it go, all the energy gets converted into motion. Um, you can also give an object elastic energy if you compress it. This generally works better with stuff like springs. Basically, when you compress an object and you release it, it's also going to want to return back to its original position. So this also works with elastic, and this also works with springs. That's why it's usually called elastic slash spring potential energy, because compression is also a way of giving an object elastic potential energy. So in the chat, I want you to give an example of an object with elastic potential energy. What are some ways that you can see elastic potential energy in your everyday lives or non-everyday lives? Where can you see elastic potential energy? A slinky, a slingshot, great examples. A spring scale, Alaska. That's a swing. That's a swing. That's not a spring. Fine, fine. I'll accept that definition. Alaska apparently is an example of elastic potential energy. Definitely. Do muscles have elastic potential energy? They do. They do. That's why, like, when you flex and you don't flex, right, you are causing your muscles to contract and compress. So your muscles definitely have elastic potential energy. A suspension in vehicles, great, 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 great. That's why you have a suspension, and so when you drive, the suspension is absorbing the shock from the road. So if you have a car with a beat up suspension, you're just gonna every time you hit a rock, everyone is just going to like. So not ideal. Spring scale, great example of one. I think I swear we looked at one earlier, but I don't really remember. A hair tie, great example. That's something I relate to personally. I use a lot of hair ties on a daily basis, so I know what that like. Clicking pens. What type of energy do muscles produce? So your muscles will use chemical potential energy, and then they'll produce kinetic energy usually, because your muscles are usually used to make your body move. So your muscles will generally produce kinetic energy. Um, Clicking pens, I guess clicking pens, because you have the pens have a spring in them. Yeah. Controllers. How do controllers have elastic energy? Like if you Oh, I guess like if you on the buttons of them, they kind of, if you like press them and they like return. Yeah, I guess controllers have elastic. I never thought about it that way. Yeah, for gates limits, you add a spring in them so they get pushed back up. Yeah, I mean like yeah, any sort of. I mean, now that you think about it, any sort of controller when you like hit the button, it returns to its original position. So I think that's a good example. Not some people though. I don't know what that refers to. I don't know. You might be insulting. It's insulting a previous response. Clothing straps, if you pull on them, they'll snap back. That's true. Um, those snap lights where you break them and they light up, I feel like that's a chemical potential energy, I think. Yeah, I feel like that's a chemical potential energy when you break them. I'm not entirely sure. I actually don't know how those snap lights work. So you could be right. I'm honestly not really sure. I'm not an expert on that. Um, I'm not an expert on low budget lights. It's someone called glow stick snap lights. Glow sticks. That's a TBT to like first grade. Um, So the last kind of energy we're going to look at is electric potential energy. And this is the energy that is stored between two charged objects. So this is like a wall of text. So I'm going to just try to talk about it. So basically, electric potential energy is energy that two charged objects have. It's very similar to elastic potential energy. Basically, the idea is if you put two like charges, so positive and positive, negative and negative, they do not like each other. So in order to, if you bring them close together, you are doing energy. You have to use energy to do so because they naturally repel each other. They don't want to be near each other. So by bringing them close together, you are using energy, and then you are effectively storing energy by bringing them together. When you release the two charges, they're going to move away from each other, and that potential energy is going to get converted into kinetic energy. One way you can see electric potential energy is through a battery, actually. So what happens how a battery actually works is I have a battery right here. So what you have is you have a positive end. Positive end, I think, honestly, I don't know my batteries that well. I think the positive end, basically what happens is it separates the electrons. There's one side of this will have a lot of electrons. The other side of this doesn't have a lot of electrons. And so when you complete the circuit, the electrons will flow together. And so the way the battery works is you are effectively separating electrons from from protons essentially. In order to do this, you require energy. When you complete the circuit, you are effectively letting the two objects go next to each other, and that releases kinetic energy, or that releases energy, and that basically gets converted into kinetic energy in the motion of the particles. So yeah, so basically, electric potential energy is when you separate unlike. Well, I mean, if you separate unlike charges, or if you separate unlike charges, or if you bring close charges together, they'll have more potential energy, and vice versa. Yeah. So another example is electricity and lightning. So basically what happens is in a storm cloud, you have the bottom of it becomes negatively charged and the ground becomes positively charged. And then basically because the two charges are attracting each other, there's going to be electric potential energy between the two, and then that gets released as lightning. Basically, it just has everything to do with separating charges. And then when you separate charges, they do interesting things. Okay, so that is pretty much all you need to know in terms of the 8 different types of energy. These energies can transform in each other, and we will talk about that next class. But for the rest of today, what we're going to do is I added a section on the Roller Coaster Tycoon. I think it's part 6, underneath the big heading that says energy. I added a new part to it. The new part is basically what you're going to do is you're going to identify all 8 types of energy that can be found in or near your roller coaster. So basically, on your design, I want you to say, okay, I can find kinetic energy here, I can find gravitational energy here, whatever. And I want you to try to identify all 8 types. I want you to identify all 8 types of energy. So you can, in my opinion, identify all 8 in your roller coaster. However, if you are struggling to identify all 8 within the roller coaster, you can also try to identify them outside of the roller coaster. So like maybe a pedestrian, or maybe like maybe like a food stand or something. You can try to identify elsewhere if you are having a hard time identifying within the roller coaster. But I want you to try to find as many types of energy as you can in the roller coaster itself. because then you can sort of see how the energy transforms from one into the other. So basically, I want you to find all 8 types of energy in the roller coaster. And I want you to identify the 8. I want you to explain why those energies are found there. So if you just say the roller coaster has blank energy here, I want you to identify why it has that energy. And then I want you to just label where you can find the energy on your design. So like put a little arrow that says this part has this energy or this part has this energy. Yeah. So identify all 8 types of energies that we found where, why you can find those energies there, and try to label the 8 different types of energy. So I'll give you guys the rest of the period to do so. That should be hopefully be enough time to get you a good place to start. So yeah, we'll have 20 minutes. Let's see how much of this you can do. Okay, so we're out of time now. It's 9:54. We're going to keep talking about energy for the next few days. And then we'll have at the end, we'll have some more work time. So that should be it for today. In terms of homework, you don't have any. But I would recommend trying to be caught up soon. Yeah, because I think instructionally we only have 6 days left after today, so that's not a lot of time. So I try recommending being caught up soon. Other than that, I will see you guys on Monday.
Thank you.
Thank you.
Thank you.
Bye bye.